Okay, so the first problem on this test, graphing two different functions. So the first one we need to graph is f of x is equal to 2e to the x minus 1 plus 3. So just like always, we start with the parent function, which is going to be e to the x. And then the first transformation, e to the x minus 1. The second one we need to do 2e to the x minus 1. And then the third one, 2e to the x minus 1 plus 3. So let's just start over here with the first graph of e to the x. So this is just one to have memorized. Kind of looks like this shape. And 2 points we could plug on here. If we plug in 0, we're going to get the point 1. And if we plug in 1, we get the point e. So we move on to the next one, the first transformation, the x minus 1. So that minus 1 moves everything over to the right 1 unit. So basically the same shape. However, this point gets moved over to the right 1 unit. So now it's going to be at the point 1, 1. And this gets moved over to the right 1 unit. So now it's going to be at 2e. So here is e to the x minus 1. And then the next graph, the 2e to the x minus 1. So this is where we just multiply all the y values by 2. So it's still roughly the same shape. So this y value has a y value of 1. We multiply it by 2, turns into 2 then. So now this is going to be the point 1 comma 2. This has a y value of 2. Or sorry, this point right here has a y value of e. We multiply that by 2, it becomes 2e. So now we have the point 2 and then 2e. And this is 2e to the x minus 1. And then the last graph, when we add the 3, so this is going to move everything up 3 units. And so remember, now we have to move the asymptote up 3 units. So now it'll get close to that line. That's the line of 3. And then all the y values get added to 3. So this has a y value of 2. If we add 3 to that, it becomes 5. So that's going to be at the point 1 comma 5. And then the last point over here, this has a y value of 2e. If we add 3 to it, it becomes 2e plus 3. So this is going to be 2e plus 3. And then this would be the last graph. And it's roughly the same thing for the log one. I don't think we need to do that. It's basically the same idea, just moving the graph around and everything. Let's move on to number 2. So we want to find the inverse function. Find f inverse of x. So for the first one, we have the equation f of x is equal to 2x minus 1 over 3 minus x. And so what we do here is just replace f of x with y. We say y is equal to 2x minus 1 over 3 minus x. And then we want to solve for x. So the way we do that is we're going to multiply the 3x onto the other side. So we'll have y 3 minus x is equal to 2x minus 1. So all we did here is just multiply this over to the left. Then we can distribute the y. So we're going to have 3y minus xy is equal to 2x minus 1. Now let's get the x's on the same side and everything else on the other side. So we could add the xy over to the right, and then we could add this 1 over to the left. So doing that, we will have 3y plus 1 is equal to xy plus 2x. And then on the right-hand side, we could factor out the x. We have 3y plus 1 is equal to x y plus 2. And the last thing to do to solve for x is divide the y plus 2 over to the left. So 3y plus 1, y plus 2 is equal to x. And then we're basically done, because again, remember we have, so if f of x is equal to y, this is the same thing as x is equal to f inverse of y. So we have x right here. Well, x is the same thing as f inverse of y. So what this tells us is that f inverse of y is equal to 3y plus 1 over y plus 2. Remember this y, it doesn't really mean anything special. It's just like a placeholder. It just means whatever we put here goes here, here, and here. So we could just turn that y into an x. So we could say f inverse of x is equal to 3x plus 1 over x plus 2. Okay, and then part B, let's do that. That one doesn't take too long. So for this one, we want to do that same thing with just f of x is equal to 3x minus 1. So just like before, y is equal to 3x minus 1. Just replace f of x with y. And now solve for x. So we want to add the 1 over to the left. So we have y plus 1 is equal to 3x. And then just divide by the 3. Y plus 1 over 3 is equal to x. And just like before, we have this little thing up here. If f of x is y, that just means x is f inverse of y. So we have x right here, which is the same thing as f inverse of y. So we have f inverse of y is equal to y plus 1 over 3. So there. Okay, so problem number 3, using the inverse function property to verify if the two given functions are inverses. So remember the inverse function property is, let's write it all out. So if f and g are inverses of each other, then has to equal x. So if we take the composition of the two, it has to equal x. So basically all we have to do is just take the composition of these two functions that are given in parts A and parts B and see if the composition is equal to x or if it's not equal to x. If it's equal to x, then they are inverses. If it's not equal to x, then they're not inverses. So for part A, the two functions that we have were f of x is equal to 3x plus 4, and g of x is equal to x minus 4 over 3. So calculate this, f composed with g of x. We want to see if this is equal to x or not. So what this just means is f, and we're going to plug g of x inside of it. So f is 3x plus 4, so this is going to be 3 g of x plus 4. G of x is x minus 4 over 3, so this is going to be 3 x minus 4 over 3 plus 4. So over here, these 3's are going to cancel, so we're just going to be left with x minus 4. So we'll have x minus 4 plus 4, which is just equal to x. So what we have is f composed with g, it does equal x. So what this tells us is that f and g are inverses of each other. Okay, so part B, we have f of x is equal to 1 over x plus 1, and g of x is equal to x minus 1. So we want to do the same thing. We need to calculate what is f composed with g of x. So this is going to be, f of x is 1 over x plus 1, so we're going to plug g of x into that. So it's going to be 1 over g of x plus 1, which is, so g of x is x minus 1. So this is 1 over x minus 1 plus 1. So this is going to equal 1 plus x minus 1 over x minus 1 after we get the common denominator. And this will equal just x over x minus 1. But this is not the same thing as x. So what we have here is f composed with g of x. This does not equal x. So f and g are not inverses of each other. All right. So next one, we have problem number 4. Okay, so expanding the logs. Let's just do part B. So what we want to do is expand the log, and what part B says is we have natural log 1 over x cubed z squared. So the first thing that we can do is, well, we have division. We have 1 on the top and this piece on the bottom, so we can subtract the two logs. So we can have natural log of 1 minus natural log of x to the 3z squared. Natural log of 1 is 0, so this is going to be 0 minus natural log of x to the 3 z squared. And now to expand a little bit more, well, we have multiplication on the inside here, so we can break that up with addition. So we're going to have the minus sign, and this piece right here is going to turn into natural log of x to the 3 plus natural log of z squared. So this is then the last thing we can do is we have these powers, we can move them into the front. So this would be minus 3 natural log of x minus 2 natural log of z, sorry, plus 2 natural log of z. And then we could distribute the minus sign. So we'd have minus 3 natural log of x minus 2 natural log of z. Okay, the next one we want to combine into a single log. So problem 5, combine into one log. So part A, we have 2 natural log of x minus 3 natural log of xy. So the first thing we want to do is we want to bring these numbers on the inside as powers. So doing that, our first line will be natural log of x squared minus natural log x to the 3 y to the 3. Then the next thing we want to do, we have subtraction. We have this whole log minus this whole log. So we can write one log symbol and then just divide the insides. So this is going to be natural log. We have x squared on the top, and on the bottom we have x to the 3 y to the 3. And in the last step, we can cancel 2 of these x's with 2 of these x's down here. So what we have is natural log of 1 on the top, x, y to the 3. Okay, for part B, log of x squared minus 1 minus log of x plus 1. So we're subtracting 2 logs. We can just write one log symbol and divide the inside. So x squared minus 1 is on the top, x plus 1 is on the bottom. So the next thing we can do is we could factor the top. This is going to be x plus 1. This is going to be x minus 1 all over x plus 1. And then those x plus 1's cancel. So all we have is log of x minus 1. Okay, okay, so number 6 is we have to solve some of these equations for x. Let's go through all 3 of these. So the first one we want to solve is 4, 1 minus x is equal to 16, 2x minus 1. So what we could do here is we could take the log base 4 of both sides. So we're going to take log base 4 of the left for 1 minus x, and log base 4 of the right, 16, 2x minus 1. And now what we're going to do is we're going to bring those powers into the front. So on the left-hand side, we have a power of 1 minus x, and log base 4 of 4. On the right, we're going to have 2x minus 1, log base 4 of 16. So log base 4 of 4 on the left, that's just 1. So we have 1 minus x. And then notice this off to the side, if we had log base 4 of 16, this is just the same thing as log base 4 of 4 squared. And we can bring that 2 into the front. So this is going to be 2 log base 4 of 4, which is just equal to 2. So then on the right-hand side down here, what we can simplify this is, so this log base 4 of 16, that just simplifies to 2. So we have 2x minus 1. So we have 1 minus x, and then distributing the 2, we have 4x minus 2. Then what we can do is we can add, so to solve for x, we can add this 2 over to the left, and then we can add this x over to the right. And so we would have 3 is equal to 5x, and then x is equal to 3 over 5. B, we have 2, 4x minus 1, 3, 2 minus x. So for this one, we can either choose to take the log base 2, log base 3. Yeah, we can do any log on both sides. It doesn't really matter. Let's just do log base 2 of both sides. So if we did log base 2 of 2 to the 4x minus 1 is equal to log base 2 of 3 to the 2 minus x. On the left-hand side, we can bring that power of 4x minus 1 into the front. And we have log base 2 of 2. On the right, we can bring that power of 2 minus x in front, and we have log base 2 of 3. So on the left-hand side, it's just 4x minus 1. The log base 2 of 2 is equal to 1. On the right-hand side, we can't really simplify log base 2 of 3. So what we want to do is distribute this. We're going to have 2 log base 2 of 3, and then minus x log base 2 of 3. So just distributing this to here and distributing this to there. Now we want to get the x's on the same side. So let's move this over to the left and move this minus 1 over to the right. So we're going to have 4x plus x log base 2 of 3 is equal to 1 plus 2 log base 2 of 3. And on the left-hand side, we could factor out the x. And then divide the 4 log base 2 of 3 over to the right, and that gives us x is equal to 1 plus 2 log base 2 of 3 over 4 plus log base 2 of 3. And this would be our answer. Again, your answer may look a little different if you chose to take the log base 3 of both sides or chose to take the natural log of both sides. This is just one way to do the problem. Okay, part C, we have log base 2 of x plus 3 plus log base 2 of x plus 4 is equal to 1. So what we want to do is combine the left-hand side. So this combines into log base 2 x plus 3 x plus 4. That's equal to 1. Now what we want to do is take the power of 2 on both sides to cancel out that log. So we're going to have 2 log base 2 of x plus 3 x plus 4 is equal to 2 to the 1. So we're taking 2 to this side and then 2 to this side. Now on the left-hand side, that 2 log base 2 is going to cancel. So we're just left with x plus 3, x plus 4. On the right-hand side, 2 to the 1 is just 2. Simplifying this, so foiling out the left side, we're going to get x squared plus 7x plus 12 is equal to 2. Then we subtract the 2 over, we get x squared plus 7x plus 10 is equal to 0. Then we factor. This factors into x plus 2, x plus 5. So that's equal to 0. And this tells us we're going to get x is equal to minus 2 and x is equal to minus 5. But we have to check both of these answers. So notice if we plug minus 5 into either of these places, it only needs to be one. But when we plug it into both of these places, we get a minus sign. And so we have to get rid of that answer. So this one does not work. So no good. But if we plug in minus 2 up here, that's going to get positive inside this log, so that's okay. And if we plug it in there, it's also going to be a positive number. So our only answer is going to be x is equal to minus 2. Okay. Problem number 7. Let's just do, they're both the same. Let's do part A. So we want to solve 2x minus 3y is equal to 7. 4x plus 5y. 4x plus 5y is equal to 2. So we need to do some type of elimination to get rid of one of these variables. So what we can do is we could take, so notice we have a 4x here and a 2x here. So what we could do is just take the top equation and multiply it by 2. And then that would match the numbers in front of the 4, or sorry, in front of the x. So if we multiply the whole top equation by 2, we're going to get 4x minus 6y is equal to 14. And then just rewrite the bottom equation. 4x plus 5y is equal to 2. And now what we can do is we could subtract these two equations. So we're going to have 4x minus 4x, so the x's go away, which is what we wanted. And then we'll have minus 6y minus 5y, so minus 11y, and 14 minus 2, which is 12. Then we divide by the minus 11, so we get y is equal to 12 over minus 11. So there's one of our answers. And now what we need to do, let's just take any of our beginning equations. Let's take the first one. 2x minus 3y equal to 7. And then let's plug this y value into here. So doing that, we're going to get 2x minus 3, 12 over, or minus 12 over 11, because we're replacing y with 12 over minus 11. So this is equal to 7. So all we're doing is we're replacing the y value, we're plugging it in right there. All right, so what is the simplified to? We have 2x plus 36 over 11 is equal to 7. We have 2x is equal to 7 minus 36 over 11. 2x is equal to, so the common denominator is going to be 11, so we'll have 77 over 11 minus 36 over 11. So we have 2x is equal to 77 minus 36, which is 41, so 41 over 11. And then if we divide by the 2, we will get x is equal to 41 over 22. So both of our answers, we have y is equal to 12 over minus 11, and x is equal to 41 over 22. Okay, the last problem from this test, problem number 8. So we wanted to solve that systems of equations, x plus 2y minus z is equal to 1, and then we had x plus 2y plus 2z is equal to 7, and then we have 2x plus 6y plus z is equal to 8. Okay, so let's turn this into a matrix. So that matrix will have 1, 2, minus 1, and 1. Then 1, 2, 2, 7. And then 2, 6, 1, 8. So remember, the first step is always to make this top left piece a 1, which is already done for us. And then we want to make the pieces beneath of it a 0. So what we're going to do for our first step is leave our first row the same. And then to make this a 0, we can just subtract one of this row. So row 2 minus row 1. And then to make this piece a 0, we can subtract 2 of this row. So what we could do is do row 3 minus 2 row 1. So rewriting row 1, 1, 2, minus 1, 1. Row 2 minus 2 row 2 minus row 1. So we're going to have 1 minus 1, which is 0, 2 minus 2, which is 0, 2 minus negative 1, which is 3, 7 minus 1, which is 6. And then the last one, we have row 3 minus 2, row 1. So 2 minus 2 times 1, which is 0. 6 minus 2 times 2, so 6 minus 4, which is 2. 1 minus 2 of this, so 1 minus a negative 2, which is 1 plus 2, which is going to be 3. 8 minus 1 times 2, which will be 6. So one thing we can do now, let's look at this matrix over on the right-hand side. So what this look at our row 2. What our row 2 tells us is that 3 times z is equal to 6, because we have 0x, we have 0y, 3 times z is equal to 6. And then we can easily solve for z now. We see z is equal to 2. So there's one of our answers. Now look at the third row. So our third row tells us that 2y plus 3z is equal to 6. But now what we can do is we can plug this z is equal to 2 into here. So we get 2y plus 3 times 2 is equal to 6. So that 3 times 2 is just 6. So we can subtract it over to the other side and to see that 2y is equal to 0, which means that y is going to be 0. So now we found z, now we found y. And then if we look at the first row of this matrix over here, row 1, what this tells us is that x plus 2y minus z is equal to 1. And so what we could do is we could plug our y into here, and then we could also plug our z into here. So we're going to get x plus 2 times 0 minus 2 is equal to 1. So which is just x minus 2 is equal to 1. Add the 2 over, and then we get x is equal to 3.